Welcome to another session in Math Mike. Don't forget to like and subscribe. In today's video lesson, we'll be talking about geometric sequence. And let's start. What is geometric sequence in mathematics? It is a sequence which each successive term is found by multiplying the previous term by a fixed number. The fixed number is called the common ratio, which has a symbol of small letter r. A geometric sequence can be defined by iterative equation of the form a sub n equivalent to a sub 1 times r raised to the power of n minus 1, where r is a constant number. Let's have an example in solving geometric sequence. But always take note, in solving geometric sequence, you must first know the process of identifying or getting the common ratio. Let's have this example number 1. Before going to a specific term or solving a specific term of a geometric sequence, let us first identify if this sequence is a geometric. Geometric sequence can be identified if there is a common ratio. So how to get the common ratio? First thing we'll do is to test the second term, divide it by to the first term, and we have the result of a quotient which is equivalent to 3. Now, if the next quotient or the next 3 quotients at least are common directly, we can say that this sequence is a geometric. Now, let us test again this third term divided by the second term, and it results to 3. 54 divided by 18, the result is still the same, 3. Therefore, our sequence is geometric. Another example, we have 2, 4, 8, 16, and so on. All we need to do is test the given sequence using or getting the common ratio. If we divide it by 2 to the 4 results to 2. 8 divided by 4, the result is 2. 16 divided by 8, the result is also 2. So therefore, we can say now that this given sequence is a geometric sequence. Another, we have 80, 40, 20, 10, and so on and so forth. Again, test if the given sequence has a common ratio. All we need to do is divide the second term to the first term, results to 1/2. 20 divided by 40 results to 1/2. And 10 divided by 20 results to 1/2. So therefore, they have the common ratio. We can say now that this given sequence is a geometric sequence. So now, that is the main step to identify if the given sequence is a geometric or not. Let's start solving now the number 1 problem. Find the eighth term if the given sequence is 2, 4, 8, 16. Always take note that we don't have statement provided that this sequence is a geometric. So therefore, we will test the given sequence using the common ratio. So all we need to do is divide 4 by 2 results to 2. 8 by 4 results to 2. 16 by 8 results to 2. Therefore, we can say now that this given problem or sequence is a geometric. So now we can use the formula a sub n equivalent to a sub 1 times r raised to the power of n minus 1. We are looking for the eighth term. And to check all those given item, all we need to do is write that one beside. So the result is 2 for a sub 1 or the first term. Then r is the common ratio. Take note that a sub 1 denoted as the first term. Okay, that is always the first term. Then the common ratio is 2. Then our n, take note n can be identified on a problem. For example, we are looking for the eighth term, so therefore our n there is 8. So we have 8 possible numbers to be observed later. Then substitute all those given items. So we have 2 times, let's make it in quantity form, 2 raised to the power of n, which is 8, minus 1. Then apply the rule in PEMDAS. So 2, let's start first operating the exponent. The result is 7. Then 2 raised to the power of 7 results to 128. Then multiply it by 2. So 2 times 128 results to 256. So this is now our eighth term of geometric sequence. Again, always remember that we will first test the given sequence if this is geometric through common ratio. Now let's proceed to the number 3. Write the first 4 terms of geometric sequence whose n term is given by a sub n equivalent to 3 times the quantity of negative 5 raised to the power of n minus 1. So we are looking for the first 4 terms of this geometric sequence. Take note, we already identified the first term based on the given formula, which is a sub n equivalent to a sub 1. So a sub 1 here is the 3 times r, which is the negative 5 raised to the power of n minus 1. So our first term is already identified as the 3 value. So all we need to do is solve 3 more terms. So we will look for the second term. By the way, you may directly proceed in applying the multiplication of your common ratio or directly use the formula to solve that one. I will be showing you 2 possible solutions here. For example, I will be using only the common ratio. So directly, if you multiply now the common ratio to the first term, this results to negative 15. Then multiply again to the second term to get the third term results to 75. That would become positive. If you multiply now negative 5 by 75, the result is negative 100 or 375. If you already identify, same as here, the common ratio and also the first term. But what if we will be using the formula? Okay, so let us try to check if we are correct by solving the second term. All you need to do is substitute the second or the value of 2 for the second term. So we will be having a sub 2 equivalent to 3 times negative 5 raised to the power of 2 minus 1. And this results to 3 times negative 5 raised to the power of 1. Then directly to the exponent of 1 results to a constant base number, which is the negative 5. So 3 times negative 5 results to negative 15. So we are still the same with our solution earlier, which we only multiply the common ratio to the first term. How about for the third term? Let us try to solve if that is 75. All we need to do is replace n by 3. So 3 times negative 5, then raised to the power of 3 minus 1, then 3. So negative 5 raised to the power of 2. So 3 times this become 25 because 5 squared or negative 5 squared results to positive 25 results to 75. Now, if you observe, yes, still the same. And lastly, for the fourth term, all you need to do is multiply or substitute the value of the fourth term or the value of 4. So that will become raised to the power of 3. Then let us now try operate. The exponent of 3 results to 125. That will become negative because negative times negative results to negative. So negative 125. Then if you multiply that one, results to negative 375. Now, observing our answers earlier, they have the same answer, which applying the multiplication of the common ratio and using, using the formula in common in geometric sequence. Now, let's have another example or another situation in geometric sequence. Find the first term of geometric sequence whose fourth term is negative 40 and the common ratio is negative 2. The givens are a sub 4, which is negative 40, and the common ratio, which is negative 2. Now, this item here is quite simple because again, directly all you need to do is substitute based on the formula of geometric sequence. So all you need to do is substitute. So we'll be using for a sub n, which is the a sub 4. Because we have already the value of a sub 4. Then a sub 1 times r, which is the negative 2. Then our n is 4. Take note, a sub 4 has a value of negative 4. All you need to do is replace that one. So let us substitute. Then let us try to operate now the exponent. So if you subtract that one, results to 3. Because 4 minus 1 is 3. Then let us try to operate the exponent or extract the exponent here. So we have negative 2 times negative 2 times negative 2 results to negative 8. Then directly, let us eliminate now negative 8 by the property of multiplicative inverse. The inverse of negative 8 is to multiply both sides by 1 over 8. Then directly we'll eliminate now negative 8. So 40 divided by 8 results to 5. So our first term now results to positive 5. Situation number 5. Find the first term of geometric sequence whose fourth term is negative 11 and the 11th term is 11. So for this problem here, we have two given terms in geometric sequence, which the a sub 4, that is negative 11, and the 11th term, which is 11. So all we need to do is use the formula. On this situation, first thing you will do, because we don't have common ratio, all we need to do is use the formula of the geometric sequence, which is a sub n equivalent to a sub 1 times r raised to the power of n minus 1, and create two equations. So first thing we'll do is use first the smallest term, which is the a sub 4. And that would be equivalent now to a sub 1, then the common ratio. Then we have 4 minus 1. Take note, we have the value of our a sub 4, which is negative 11. Then that would be equivalent now to a sub 1 times r raised to the power of 3. So this is now your equation number 1. For equation number 2, we'll be using the highest term that we have as a given. So we have a sub 11 is equivalent to a sub 1 times r raised to the power of 11 minus 1. Then we will now operate. No, we'll substitute. So 11 is equivalent to a sub 1 times 10, or r raised to the power of 10. So this is our second equation. Now, what would be our ruling now to get a specific term on this item here, or the r? All you need to do is divide equation number 2 to equation number 1. And the result of this division is the common ratio. So let's start dividing now. Equation 1 or equation 2 divided by equation 1. Okay. Now, if we divide 11 by negative 11, the result is negative 1. Then that would be equivalent now to a sub 1 divided by a sub 1 should be cancelled out now. So there would be no value at all. There is a value that is a constant, which is 1. And if you multiply that 1 by r, the result is still the same. Okay, this is 1, correction. Okay. Okay, 11 divided by negative 11 results to negative 1. Then a sub 1 divided by a sub 1, the result is 1. So no need to write because that is constant. Then the rule in operating the exponent. Okay, the exponent of, or subtracting the exponent. If we divide with the exponent directly, same base, all you need to do is subtract the exponent. So 10 minus 3 results to 7. So we have now r raised to the power of 7. Then we will try to eliminate now this 7 by 7th root. Then 7th root. And the result is negative 1. That's it. So we already have the value of our common ratio. So all we need to do is substitute the common ratio. It's either equation 1 or equation 2 in order to solve for the first term. So let us now try to substitute using equation number 1. So our equation is negative 11 is equivalent to a sub 1 times r raised to the power of 3. So we have the negative 1 as the value. So negative 11 times or is equivalent to a sub 1 times negative 1 and a sub 1 now here results to negative 1. So eliminate negative 1 and the result is 11 for the first term. If you are using the equation number 2, they have the same answer. So let us try to check using equation number 2. So 11 is equivalent to e sub 1 times r raised to the power of 10. Then 11 equivalent to e sub 1 times negative 1 raised to the power of 10. Then operate that one results to positive 1. Okay, that results to positive 1. So if it results to positive 1, 1 times a results to a sub 1, and our a sub 1 there is equivalent to 11. They are still the same.